Well, hello Internet, and welcome to part 1 of my Java tutorial series. In this part of the tutorial, I'm going to go over all the basics that every Java program has, and I'm going to really focus in on variables or attributes and explain pretty much anything you'd ever want to know. Well, first thing you need to know is how to create a Java program, and I'm inside of Eclipse. Underneath this video, there's a link that shows you how to install Eclipse if you don't know how to use that, or of course you can use any other type of text editor and compiler or what have you. But inside of Eclipse, you go New, and then you come down here to File. And I'm going to call this guy Hello World, even though we're going to do a lot more than just the Hello World stuff in this tutorial. I'm going to call it Hello World 1.java. I'm going to hit Finish. And here we are, ready to code. Now, what I always say to people is just follow along with this the best that you can, because I believe that one of the best ways to learn a programming language is to listen someone speak it. And as I type out each individual word, I'm going to explain exactly what I'm doing. Now, inside of Java, everything is a class or an object. And what we're going to do here is define a new class or a blueprint for all the things our program needs, such as attributes or variables or storage areas for data and functions or methods or things that we need to do things inside of our program. And now how you always start these guys off is public. And what public tells Java, or the Java interpreter, is that this should be available to all other classes. Everyone should be able to execute this guy and the information that is in it. Then we're going to type in class, and like I said before, this is a blueprint for our program and what we want it to do. And then I'm going to type in exactly the name of the file that we just created. And then I'm going to have an opening curly brace followed by a closing curly brace. And all of my code is going to lie between those opening and closing curly braces. And then inside of this guy, I'm going to define a function called main that is required in every Java program you will ever create. And it is the function that always executes first. And to start it off, we type in public again. And then like I said before, public just allows all classes to use this function. Then I'm going to type in static. And oh, by the way, you always use the same sort of format, public, static. You're going to see in a second void, main, and then all the other stuff that I'm going to go over in a second. What static means is that only a class can call for this function to execute. And the class in this situation that's going to call for it to execute is Hello World. And then we're going to type in void. And what void means is it's stating that this function doesn't return any values after it is done executing. And then we're going to type in main, which is the name of our function. And don't worry about this for now, but string args, like we have right here. What this is doing is that every main function must accept an array of string objects. But like I said, don't worry about that. It can become confusing, and I don't want to confuse you, especially right here from the onset. So now inside of this, for the basic Hello World common program that people use, we're going to call an object called system out. And system out is an object that outputs information in different ways. Well, we're going to say we want to use the print line function that is inside of here, and we want it to print out to the screen, Hello World. And then we end this line of code like we end most lines of code with a semicolon. Now, if we execute this guy, you're going to see over here, Hello World pops up. So pretty simple. So I'm hoping you understand exactly how variables work. I mean, it's just a place, it's a storage area for your data. Now, let's say you wanted to create what is called a class variable. And on top of that, you want it to be able to be accessible to any other method or function you define inside of your class. How do you do that? Well, we're going to use static again, because what does static do? It allows other classes to access this. And if we know we're going to use a series of characters, well, we're going to create a string storage area. And I'm going to call this guy random string. And that is the variable name. Now, the rules for variable names is that variable names are case sensitive, so if I would have typed in random string like that with an uppercase R instead of a lowercase r, those are two totally different variables. Another thing to remember is you can start off all your variable names with either lowercase or uppercase letters, and then you can also have underscores, you can have numbers, and you could have a $sign. But most of the time you want to stay away from $signs and just stick with letters, numbers, and underscores. And then if we want to assign a value, well, remember a string contains a series of characters. We could type in string to print, right like that. And then we can take this guy right here and throw that variable down inside of there. And if we execute that, it's going to instead say string to print over here. So that's how you would create a class variable that can be used anywhere. Now, let's say you want to create a variable that is always going to remain the same. Well, again, we're going to type in static because we want everybody to have access to this. And if you want it to be what's called a constant, you use final. And then let's say that we want this to be a number that has decimal places in it. Well, in Java, by default, if you want a storage area that's going to be a number with decimal places, it is called a double. So we're going to put that in there. Another common practice inside of Java is if you're creating a constant, that the variable name should be all uppercase letters. And in this case, I'm using pi as a value for this guy. And then just to show you that it works, you can use it just like before, execute, and boom, there pi shows up over on the right hand side of the screen. And if you can't see this by chance, watch it full screen and everything will look great because it's an HD video. Okay, so now I'm going to show you a little bit more about variables. Now if you want to create a variable or use a variable, you must declare it before you can use it. Here I'm creating what's called an integer, and I'm going to give it a name, integer 1 for example. And I could just do that, and this would be called a declaration statement. And that would all be perfectly fine. If I want to also assign a value to it, which also makes a lot of sense, I could do just that. And then also understand you could also declare multiple different variables all at once by going into jur2 and then as many commas as you'd want, ended with a semicolon. But that's just the basics right there. So integer 1 we're going to say is equal to 22. Okay, that's great. Well, you could also create a new integer, and it's going to be called integer 2 in this situation. And we're going to say that integer 2 is equal to integer 1. And if you want to increase that value by 1, for example, well, that's what you do, just with a plus sign. And this is what is called an expression statement. Okay, so this is declaration statement right here, and this is an expression statement. Nothing you really need to know. But also understand that it is completely valid to say int integer 2 and put this on the next line and then put this on the next line and then put this on the next line. Java does not care about white space. Why? Because it cares about this semicolon. This tells it it is the end of the line. And then of course you could come in here, copy that, paste that in there. And if you wanted to print this to screen, you do it like that. And you can see here the 23 showed up on the screen. All right, so let's get rid of that for now. I'm going to get more in on the specifics of variables and how they're used now. Now there's a bunch of what are called primitive types inside of Java. And really the only thing that makes them different is what values they can hold. So you have bytes. And I'm going to call this big byte because it's actually going to be the biggest value that a byte can hold, which is 127. And the minimum is negative 128. Shorts, so I'm going to say big short. Doesn't really make sense, does it? Big short is equal to, and then this situation is 32,767, 32,767. And the smallest is negative 32,768. So it's just one less than what your maximum is there. For integers, big int is equal to, and this number is like 21, 1, 2, 3, 4, 5, 6, 7, 8. It's bigger than that, but basically understand that it is right around 2.1 trillion. Okay, so that is the biggest int that you can put in there. It's actually a bigger number, but not by much. Then you have what are called longs, and let's go big. Long is equal to 922, and I'll put 16 zeros after that. Okay, and then you have to always end it with L whenever you're defining a long. So that's approximately how big a long gets. Then you have floats, which are just decimal place numbers. Big float is equal to, and it's a big guy. I'm actually going to show you exactly what it is. It's kind of machine dependent. Just understand you have to put an F there at the end to be able to create a float. And then a double, in essence, is a float, except it is just a bigger, more precise float. So you can put a lot more numbers in there than you could ever do with a float. And also another thing to remember is you can put a D at the end of this double, but it is not required because it's a default that we're using doubles inside of Java if you're using decimal places. Now remember I said I could actually print out on the screen the maximum size for my float. Now I'm going to use system out, print line again, and if I want to print that I just go float dot and I'm going to type in max underscore value, right like that. And I can also do the same thing with doubles. So this is going to tell me precisely how big they are depending upon the system that I am using. might be different for the one you are using. And we can print that out and find out. And you can see there is the largest float you can create, and here is the largest double you can create. Make sure you understand here E38, these are exponents. So these are big numbers. 38 digits in length is 308 digits in length. Just understand that a float is precise to roughly 6 decimal places, and a double is precise to approximately 15 decimal places. So, like I said before, you don't need to memorize this stuff, just laying it all out there. Then you have booleans, and they are literally true or false. That is it. They cannot hold a value of 1 or 0 or what have you like other computer programming languages. They are either true or they are false. And they are not uppercase true. They are lowercase true or false. And those will come more into effect later on in the tutorial series. Then you have characters, and what they are is it's a character is either a number or a character. It's a character that is surrounded by apostrophes. So if you want to create one, you can go random. You can actually do it in a couple different ways. I'm going to go random char is equal to, and I'm going to type in 65 in this situation, and then I'm going to go character another char is equal to, and I'm going to go a, right like that. Now if we come in here and actually copy this, we can see what the difference is. Make sure you do not surround these with double quotes though. It will not work, or at least it won't be a character. So then if I want to go random char, paste it inside of there, and then let's see what this guy looks like. You can see that in uppercase A shows there on the screen, which just so happens to be the same character code as the A down here. And just to prove that I'm telling you right, I'll change it to 66. Run it again, and now you see that it is a B. So those are character codes, and I have a little bit more information underneath this about how character codes work and all the different character codes. Characters can also contain what are called escaped characters, and they are things like backspaces. So let's just call this escaped cursors like that, and they can be a backspace, which is that right there, or they can be a form feed, which is a backspace. Well, actually these are surrounded by apostrophes, just to make sure we got that all right. So like I said, backspace, form feed, line feed, carriage return, which is an R, horizontal tab, a double quote, a single quote. As you can see, we're just doing this, and then a backslash. So those are all the different escape characters that are available. Again, nothing by any means you need to memorize. You'll easily catch up and learn those as time goes by. Then you have what are called strings, and we visited them before. A string is technically an object, but like I said, I'm going to get more into that later. So let's say I create a random string, and like I did before, I'm a random string. Okay, it's just string of characters inside of double quotes. That's a string. That's all it is. And you can print that to the screen as well if you wanted to. But let's say we want to create another string, random string, and call this another string. It's equal to, and I'm just going to say stuff. If you want to combine two strings together, let's go string and another string is equal to. And you could go random string plus, and then if you want to put a space in there, no problem, just do that and put another plus sign and then go another string. And there you just combined a bunch of different strings together. And if we take this guy right here, drop it inside of there and run it, and you can see it says I'm a random string stuff. So that's how you combine strings. And let's come in here again. I'm going to show you how to convert any other type that I defined above into a string. Well, you go to create a string to hold the thing, and we can go byte string. That's just the name of the variable I'm creating. And if you want to convert a byte to a string, you would just type in byte with an uppercase B to string, right like that. And it's a function, and we're going to go in here and go big byte. And I defined that up above. So now this string called byte string is actually going to hold the value of the variable called big byte, except it's going to be a string, so it's going to be 127. And then there's actually 6 of these different guys. There's one for short, there's one for int. There's no reason for there to be one for characters or char. There's one for long, and they all follow exactly the same format. One for float, there's one for double, and boolean. And then the only thing you need to do is replace these guys with uppercase letters. So this is going to be short now, dot to string, and then of course it's going to be big short. And then in this situation it's going to be integer instead of int. And this is going to be long, this is going to be float, this is going to be double, and this is going to be boolean, except in uppercase letters. So that is how you convert any of the other primitive variable types into string types that you can use. Another thing that you learn kind of at the onset of learning how all these different things work is how to cast, or how to convert from one primitive type to another. So let's say I create a double value, and it is equal to 3.14 blah 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 blah. Okay, so there I just created a variable called a double value, and if I create an int, and double to int is the name of that variable, and I want to convert this double, which is right here, into an int. How do I do it? Real simple. I just put little braces like that and then type int, or what I want to convert it into, and then I just take the variable that I want to convert, right like that. And then if I print the screen, this new integer, you'll see right over here that it takes this big double, 3 point blah blah blah, and turns it into a 3. Now you may have a question of what happens whenever the double is bigger than the integer, meaning the space for it. Well, let's find out. Just go like that, hit return, and what it does is it puts in as many numbers as it can, or the maximum value that an integer can hold. So you can see by doing this casting and converting that a lot of information is lost along the way. But it's important to know how to do casting and so forth, so that is why I'm covering it. And if you would want to cast any of the other guys, it would just be byte, short, long, inside of braces, double. And then the final thing I'm going to show you here is how to turn a string into one of the other primitive data types. And it's pretty easy. Here's int string up right here, and let's big int. Now if I want to create a new variable called string to int, and I want to convert that string, which is right here, int string, back into an integer, well, I'm going to type in uppercase integer, and I'm going to type in parse int, right like that. And then I'm just going to pass in the string that I want converted into an integer, right like that. And I can come in here and go paste, and we can see what we got here. And there you go. We printed it out, and it is now back to being an integer after it was turned from an integer into a string and back into an integer. And there are parse functions available for all the other different types. There's parse short, there's parse long, there's parse byte, parse float, parse double, and parse boolean. And once again, there's no reason to parse a character. So there's a whole bunch of different things you can do with variables inside of Java. Leave any questions or comments below. Like I said, the code is heavily commented and underneath of this video. Otherwise, till next time.